guys, in this video we're going to be talking about formula mass and atomic weight. By the end of this video, you should be able to identify what atomic weight is, and you should be able to find where it is at. You should be able to calculate the molecular mass and formula mass in atomic mass units, and determine the empirical formula from the molecular formula. So let's first look at our atomic weight. And actually, before we look at atomic weight, I want to look at the idea of an atomic mass. So the atomic mass is the mass of a single atom in AMU. Or our atomic mass units. And it's roughly equivalent to the sum of the protons and neutrons. So our protons plus our neutrons. It'll be very close to that number. Our atomic weight, in comparison, is our weighted average of our isotopes. So the weighted average of the atomic masses of all isotopes, all naturally occurring isotopes of a given element. And we've already looked at this in a previous video where we took our isotopic abundances in fractional form, so divided by 100% if you're in a percent, and then multiplied that by the atomic mass of each different isotope, and then add that together to get our atomic weight. If we look at our periodic table, each of our element symbols will have an integer value. That's our atomic number. It'll usually have the actual chemical symbol, the 1 to 2 letter symbol that tells us what element it is. A lot of times it will have the element name. And then somewhere on there you'll see a non-integer value. And that is going to be your atomic weight. The only time you'll see it as an integer value, the atomic weight is an integer value, if it's not an actual atomic weight, because it's a radioactive substance that they've only been able to isolate, and they only really give the protons plus the neutrons. Our chemical formulas themselves are going to show what elements are in a compound or molecule and how many of each. So our elements themselves generally combine to form molecules and compounds. They are rarely by themselves. The chemical formula tells us what elements and how many of each are in a given compound or molecule. Okay. So if we were talking about a molecule, we are talking about covalent substance. And it just has to have two or more of any combination of elements. So it could be two or more of the same element, two or more of different elements. It just can't be an atom by itself. And then if we have a compound, this can be ionic or covalent. And it has to be two or more different atom types or different element types. So just as a note, we've talked about this already, but we have elemental molecules And here are some examples of some elemental molecules that you should be familiar with. So we have diatomics. This is going to include H2, N2, O2, F2, Cl2, Br2, I2. So this one right here, and then these 6 right here, and it almost looks like a little 7. There's 7 total of those diatomics you must have memorized. And then we have some polyatomics. And these are going to include P4, S8, Se4. So there's a couple of different polyatomics, and those polyatomics are right here. You do not need to memorize those. You just need to know that there are polyatomic elements in there. Then over here, we have molecules and we have compounds. So our chemical formulas are there to differentiate one molecule or compound from another. For instance, if we look at methane versus ethylene, they are both substances that have both carbon and hydrogen, but they are very different because of the amounts of each of the elements they have and the way that they are bonded. So it's very important to make sure that you write out how many of each atom you have, every type of atom you have, how many of each you have in your chemical formula. And this is going to be different from this, so make sure that you know how many of each you have. Okay, next we're going to talk about molecular and empirical formulas. So a molecular formula is what we saw above. That's when we're talking about a covalent molecule. So our molecular formula is our chemical formula for a covalent species. Okay, and this tells the actual number of atoms within the structure. And of course, what types. The empirical formula is going to be the reduced or simplified chemical formula. The empirical formula is the smallest whole number ratio of atoms in a compound. And we use empirical formulas both for ionic substances as well as covalent substances. To determine the empirical formula, from the molecular formula, you're going to divide the molecular formula by by the largest common factor among the atoms. Okay? Generally, when we're talking about a covalent substance, we always use a molecular formula. And then when we're talking about ionic substance, we always use the empirical formula. So covalent, usually the molecular formula. Ionic, always the empirical formula. So let's real quick try an example. We want to convert the following from a molecular formula into a empirical formula. So all of these are molecular formulas. In order to go from H2O2 to an empirical formula, we're going to divide by 2, and we get HO. C6H12O6, the largest common factor here would be 6, so we divide all the numbers by 6, giving us CH2O. Water, the largest common factor is 1, so it's H2O. And then in C2H6, the largest common factor is 2, so we divide by 2 to get CH3. Okay, guys, that's everything. Thanks.